Okay, so now we're going to be going over Searle's actual paper, his actual thought experiment, his actual views. So he's focused on strong AI, and he's responding to the work of Schenck. And this is happening in the 1980s. So computers were not nearly as powerful back then as they are now. So like Watson or Deep Blue didn't exist yet, but the argument still has tons of force now. It's still applicable to the way that computers are working now. So Schenck argued that you can program a computer to answer questions about a story like Little Red Riding Hood. And Schenck thought that the computer understands the story if and only if it answers all the questions correctly. And he thought that it's in theory possible to program a computer to do this. So it's a weaker, limited version of the Turing test. It's a much easier test to pass because instead of it involving anything about deception, all the computer has to do is answer the questions appropriately. So what are some examples of some questions? Is Little Red Riding Hood's grandma male or female? Is the wolf a vegetarian? What color is Little Red Riding Hood's hood? So there are an indefinite number of questions you could ask about the story. And how would this work? Well, you would feed the story into the computer, you'd type into the computer a question, and your written typed words would be transformed into zeros and ones. The computer produces a different series of zeros and ones, which then gets converted by the program into pixels, and then it gets put up on the screen, and then you read from the screen to figure out whether or not it's the correct answer. And if the answers are correct, according to Schenck, the computer understands the story. And the questions don't have to have a definitive answer. So you can answer crazy questions, or you can ask crazy questions like, is the lumberjack quantum mechanic? Does he know quantum mechanics? For the computer to answer this question appropriately, it would have to say something like, probably not, that's irrelevant to the story. But the questions you want to ask the computer should require some logical manipulation. Like you don't want to just ask questions where the computer can just copy and paste the answer. So consider the question, is the wolf a vegetarian? So how does the computer answer this question? How do you do it, right? What's your reasoning process? I'm guessing you might have thought, well, vegetarians don't eat meat. Grandma is meat. The wolf ate the grandma. Therefore, the wolf is not a vegetarian. Now, you did that probably pretty fast and it was unconscious. If the computer is answering these questions correctly, it's not implying that the computer's conscious, because you did it unconsciously. The idea here is that the computer can do this because it has inputted into it the meaning of the word vegetarian, like what it means to be a grandma, which is like a human being, which is a meat. It has concepts of these sorts of the words. So what does Searle want to refute? Either the computer can answer the questions or the computer understands the story. And as you can tell by my check and X, Searle is not refuting the thesis that the computer is able to answer the questions. He believes that yes, we can program a computer to answer the questions appropriately. What Searle is refuting is the idea that the computer understands the story. And that's the difference between weak AI and strong AI. Weak AI is just the ability for the computer to answer the questions, and Searle doesn't dispute this. Strong AI is the thesis that the computer understands the story, and that is what Searle is refuting. More generally, Searle's thesis is that following a program is not sufficient or necessary for understanding the story. Or in this case, it's the story, but you can just say following a program is not sufficient or necessary for understanding in general, any kind of understanding. So the steps the computer uses to answer the story might be a result of following a program, but if Searle is correct, then it is nothing like the way that you and I answer the questions is nothing like following a program. It's something totally else, totally different, something else. The Chinese room thought experiment, this is the famous thought experiment, probably top 5 famous philosophy thought experiments ever. So we stick a guy in a room. So this little box is representing a room. So we stick one guy in there and we're just going to say it's Searle. So because Searle says it's him in his paper. So we stick Searle in a room and we seal him in there and we give him this huge book, right? The rules. And there's this little slot on the side of the room right here. And Through this slot, we send him Little Red Riding Hood in Mandarin. So it's written in Mandarin. Searle does not speak a word of Mandarin. He doesn't even know that Mandarin is a language. Okay, he has no idea. He looks at the symbols in this book written on these pages, and he doesn't even want to say, he doesn't say they're symbols because he doesn't think they stand for anything. To him, from his point of view, they're just like, could be accidental pigeon droppings on a piece of paper, or like a pigeon walked on some paint and then walked over the paper. That's what it looks like to him, this book, Little Red Riding Hood in Mandarin. And so we're not even going to say that it's gibberish, because gibberish implies that there's some intentionality behind, something intentional going on. It's supposed to look and sound like a language. No, here, Searle, looking at the Mandarin Little Red Riding Hood, is just thinking, okay, this is an accidental scribbles, just like I was holding a pen and the paper was in the way, and I was like talking, gesturing, and then I looked down and the pen had written all over the paper. That's to Searle what this book looks like. So there are people standing outside of the room, and they start sending him through this little slot questions in Mandarin about Little Red Riding Hood. So Searle, these questions are in Mandarin, so he gets these pieces of paper, and he doesn't know that they're questions. He still doesn't know it's a language. He thinks it's just more accidental scribbles on a piece of paper. So he has this big book of rules, and this book of rules has some English written on it. So the book says, if you see this marking, shove this marking out of the slot. So he gets the question. He finds the marking that matches in this rule book. Then the rule book says, send out this marking. So then he writes that marking down on this piece of paper, and he shoots that out back to the people standing outside of the room. So that's all he does this entire time. They shove questions about the book in Mandarin to him. He doesn't even know the language. He thinks it's accidental scribbles. He checks his rule book. So he matches up one set of scribbles with a different set of scribbles. He writes that second set of scribbles down on a piece of paper, and he shoves it back out to these people outside. And that's all that Searle does inside of the room. So these people out here are native Mandarin speakers. So they understand Mandarin like you and I understand English. So Searle says that the Chinese people who read and write Chinese and have read Little Red Riding Hood, when they see the cards coming out of the box, the answers, they understand that the answers are appropriate, they're correct, and they're cogent answers to the questions that they put in. But yet, Searle wants to say that he does not understand the questions, the stories, the answers, nothing. He understands nothing about Little Red Riding Hood, yet he is producing the correct answers to all of the questions. Searle further wants to say that this is what following a program is, and yet he has no understanding of anything. So what language is the program written in? English. So this rule book is written in English, and he understands English. He's doing what you and I did when we answered questions. Like, we follow this set of rules by following this rule book. But the actual understanding of the story, the understanding of the questions, the understanding of the answers, none of that exists to Searle. All Searle understands is the rules, but the rules are not the story. So according to Searle, this proves that following a program is not sufficient for understanding. Where sufficient here is being enough. So he's following a program, but he still doesn't understand the story of the questions. And if sufficiency is about being enough, this is showing that following a program is not enough for understanding. So this is only part one of the argument, because again, his thesis here is that it's not sufficient or necessary. So far he's only focusing on the sufficiency part. And here's his argument. Premise 1, Searle understands nothing about the story. Premise 2, Searle is doing nothing but following a program. Premise 3, if 1 and 2, then following a program is not sufficient for or not equivalent to understanding. Therefore, following a program is not sufficient for or equivalent to understanding. So just a little quick tidbit or side discussion here. Notice that Turing did not give us the thought experiment. He gave us a real experiment, a real method to test thought in computers. The Turing test is something you can actually design, perform, and run the test. And it specifies exactly what would qualify as passing the test. That's not what Searle's doing. Searle is giving you a thought experiment, something you're supposed to think about and from your intuitions draw some conclusion. And he says consider some other variants of this. So suppose we put a native Mandarin speaker in the Chinese room. So suppose this guy in here is a native speaker. This native speaker would be giving the exact same answers to the questions as Searle did. But Searle wants to say there's a huge difference between a native speaker giving the answers and Searle himself giving the answers. And the difference is the native speaker understands the story, understands the questions, and understands the answers, whereas Searle doesn't understand anything and is just following the program, following the rule book. So let's talk a little bit about sufficiency and necessary conditions. So A is sufficient for B means by definition that A guarantees B, A is enough for B. All you need to get B is A. If you have A, then you're inevitably going to get B. Whereas when A is necessary for B, it means that A is indispensable for B, but it might not be enough. You might need more. So let me just give a couple examples. The temperature being below 32 degrees is necessary for snow, but it's not sufficient. You need precipitation too. So it's impossible for it to snow without the temperature being 32 degrees. But even if the temperature is 32 degrees, it's not going to snow unless there's some precipitation. Another example, water falling from the clouds is sufficient for rain. If water is falling from the clouds, then you have rain. You don't need anything else to get the rain. You might be trying to dispute, like maybe you're doubting that what Searle's doing in the Chinese room is what a computer does when it follows a program. But the argument here is that computers effectively take an input, they follow a rule, and they produce the output. So Turing proved back in the 30s that every program can be reduced to a computer doing nothing but changing ones into zeros and zeros into ones in accordance with a set of rules. So that's Turing proved this, the Turing Church's thesis. And this was the foundation for our laptops and all our modern technology. So once people realized you can turn high voltage and low voltage into ones and zeros, or magnetic spin up versus magnetic spin down into zeros and ones, all the higher level programs were reducible or could be converted into changing zeros into ones, high voltage and low voltage, which is all that ever happens in any computer. So this is all it is, changing ones into zeros and zeros into ones. And it does seem like what Searle's doing in the room by following that rule book is what a computer does when it follows a program. Searle in the room understands that he's following a program. He understands that he's following rules. He understands English. But in order to understand the program, he has to understand English in order to understand the program. But understanding the rules does not entail understanding the story. And that's what's important here is, does he understand the story? And so the first objection here is that it's not the man in the room who understands the story. You have to think about the man in the room plus the whole room and the setup and the rule book and everything together. And all of that together, that conjunction is where the understanding is. It's not simply the man. So Searle responds to this by presenting another thought experiment where you're supposed to imagine that Searle memorizes the rule book. So he no longer has to go look at the rule book, find one squiggle, see what corresponding squiggle aligns with that squiggle, and then send out the answer. He has memorized all of those rules. So now he doesn't need the book. He doesn't need the room. He can still give the correct answer to all of the questions. So you just hand him the card and he'll give you the correct card. So I kind of stacked the deck against Searle here with all my talk about language processing being pretty much unconscious. But the idea here is still that Searle, the guy in the room, does not even know that this is a language. So it's still different from what we're doing Because at the very least, you do know that when I'm speaking to you right now, I'm speaking a language. You know that, you have awareness of that. So even though the language processing is unconscious, you are conscious of the fact that a language is being spoken to you. In this thought experiment, we're supposed to take that away from this. We're supposed to say, no, the man in the room, Searle in the room, isn't even aware that a language is being utilized when he hands cards back and forth to the native speaker. And he's going to try to address this a little bit later on, but for now, that's his preliminary response. Another preliminary second objection is that what's going on with the man in the room is just pretty much what's going on with the neurons in our brain. So the neurons in our brain engage in a process of input and output without any understanding. So the specific neuron in your brain doesn't understand anything. It's like a cellular organism. But when you put all the neurons together, then the brain has that understanding. You have that understanding. So it's just an analogy of what the brain is. Searle's response here is another thought experiment. He wants to say that if you took all the people in China and you break them up so that they are all in the same input-output relationship to one another as the neurons in your brain are to each other, and then you give all these Chinese people inputs that are meaningless to them, just as the cards are meaningless to Searle in the room, and all the Chinese people produce the correct output, you would still have no understanding distributed amongst the entire population of China. So all these people still would not have any understanding despite the fact that they're able to produce the correct answer. So from the fact that you have no understanding as an individual, it's no surprise, according to Searle, that you're not going to have any understanding as a collective. So just adding a lot of people to the scenario doesn't increase understanding. You can't get understanding from zero understanding. Now, the whole point of these thought experiments is to elicit some intuition about the problem. And I think this thought experiment might be a little bit too abstract, too far out to elicit that strong of intuition. So it's not his best argument, but it's still bringing home the point that collective is not going to get understanding when individuals don't have any understanding. So a lot of this revolves around this, understanding, like what does it mean to understand something? Like what does it mean to understand the story? What does it mean to understand the questions and the answers? And what's Searle's definition of understanding? Very similar to Turing, Searle does not actually give us a definition. So Turing did not actually give us a definition of thought. If you guys remember, he thought that if we try to define thought, it's way too vague. People are going to come up with different criteria. There's never going to be any kind of universal agreement on the definition. So rather than give a real definition of thought, he gives an operational definition, one that we can build on from science. And from our scientific methods and discoveries using this operational definition, we might get some information about what actually is thought, what is the real definition of thought. Searle thinks the same thing about understanding. He says that understanding, we can't define it. It's way too complicated of a word, but we all know what it is when we see it. Like, you know what it means to understand something. You might not be able to define it, but you know understanding well enough to know that the guy in the room, Searle in the room, does not have it. So Searle says, instead of debating about what understanding is, and instead of trying to define it when we can't, instead of trying to do an operational definition that's probably not going to capture what understanding is, despite all of that, we can still agree absolutely that the guy in the room does not understand the story. He does not understand the answers. He does not understand the questions. He does not understand Mandarin. And that's the only agreement that Searle needs. If we agree that the man in the room does not understand Mandarin, doesn't understand the story, answers, or questions, then Searle's point has been made. His argument has been fulfilled. Whatever the actual definition of understanding is, it's not being captured by following a program. So what about necessity? So where is his argument for that following a program is not necessary for understanding? He doesn't have a deductive argument for it. So he gives us a nice deductive argument for his rejection of sufficiency right here. This is a valid argument, and if you buy the Chinese room thought experiment, it might be sound. So you might agree that following a program is not sufficient for understanding. But he hasn't given us anything for necessity yet. I'm going to cover that next video, but let me just talk briefly about why is it even important to talk about necessary and sufficient. Following a program is not necessary for understanding, then that means that following a program is not even anything, it's not a part of the story of understanding. It has nothing to do with understanding. It's completely irrelevant towards understanding. So if Searle can show that it's not necessary or it's not sufficient for understanding, then he has shown that following a program is completely irrelevant for understanding. And I'll give you a quick little example to show that. Knowing what time it is not necessary or sufficient for knowing what school you go to. So let me just spell that a little bit more. If you know what time it is, you are nowhere closer to knowing what school you go to, because the two ideas are completely unrelated to one another. Knowledge of time is completely irrelevant for knowledge of school. So if Searle is correct that following a program is not necessary or sufficient for understanding, then it doesn't matter whether or not computers follow a program and are able to answer questions correctly, because following the program has nothing at all to do with understanding. So it seems like, if Searle is correct, that computers will never have understanding because all computers do is follow a program, and following a program is not necessary or sufficient for understanding. So following a program is just as relevant to understanding as time is for knowing what school you go to. So that means they're totally unrelated. So it doesn't matter at all that computers follow a program and can answer questions correctly. They don't understand anything. And that, of course, has huge implications for our own cognition, that we do have a lot of understanding about a lot of different things. So it must be the case that we're not following a program. We got to be doing something else to get this understanding. And it can't be anything like what computers do when they answer questions correctly. But this all depends on whether or not we buy Searle's argument for rejecting the necessity of following a program for understanding. And that's what I'm going to cover next video.